Welcome to my algebra class. We're on chapter 8, section 1, and we're going to be working with equations in two variables. When we had equations with one variable, our solutions were just simply numbers. If we have two variable equations, our solutions are pairs of numbers. For example, we're going to be using ordered pairs x. The number that works in this equation for x goes in the first spot in the ordered pair, and the number that works for y goes in the second spot. Now we can use different letters for the two variables, such as a and b, m and n, but whatever you do, make sure that you write those numbers in alphabetical order according to their variables. So with that in mind, we're going to go ahead with our assignment. So you need a piece of paper headed, and it's page 351, written 1 to 20, and we're doing number 2. The problems, you have to state whether each ordered pair is a solution of the given equation. So I want you to substitute in and show that it either works or it does not. So here we have 4m minus 5n equals 9, and our first ordered pair we're testing is 6, 7, so 6 will be m and 7 will be n. So 4 times 6 minus 5 times 7, we're seeing if that makes 9. That's 24 minus 35, and 24 minus 35 is negative 11, and that does not equal 9. So our answer is no for that one. And the second ordered pair, we're going to be putting in 6, 3. 6 will be m and 3 will be n, so this time we're going to get 4 times 6 minus 5 times 3, and we're going to see if it makes 9. 4 times 6 is 24, minus 15 equals 9. That one does work. So that's yes. So our answer is first no, then yes. Number 4, our equation in two variables is 3a minus 5b equals 21. And the first ordered pair we're testing is 7, 0. So 7 is going to go in for a, and 0 is going to go in for b. So substitute them in, we get 3 times 7 minus 5 times 0. 3 times 7 is 21, minus 5 times 0 is 0. Whoops, that's 21. Equals 21, and that's true. So that's a yes. That is a solution. It solved the problem. Now we're going to check the ordered pair negative 2, negative 3 to see if it's a solution. So plug in negative 2 for a, 3 times negative 2, minus 5 times b, which is now negative 3, and see if that makes 21. 3 times negative 2 is negative 6. A negative 5 times a negative 3 is a positive 15, equals 21. So that's going to give you 9 equals 21. And that doesn't work. So that answer is a no. Problem number 6. The equation in two variables is 5x minus 4y equals 9. Our first ordered pair that we're testing is 7, 6. And 7 is x, and 6 will go in for y. So plugging them in, 5 times 7 minus 4 times 6. We're going to see if that works. It makes 9. 35 minus 24 equals 9. 35 take away 24 is 11, and that does not equal 9. So that's a no for that ordered pair. Second ordered pair to plug in is negative 3, negative 6. So 5 times negative 3 for x minus 4 times negative 6 for y. 5 times negative 3 is negative 15, and negative 4 times the negative 6 is positive 24. Equals 9. The signs are different. We subtract, and we get 9 equals 9. So that's a yes. That is a solution, an ordered pair that works for the variables. Problem number 8. The equation is 3m minus 2n equals 6. The first ordered pair we're testing is 0, 3. 0 will go in for m, and 3 will go in for n. So 3 times 0 minus 2 times 3 equals 6. 3 times 0 is 0, a negative 2 times 3 is negative 6, and that does not equal 6, so that's a no. Second ordered pair for m and n is 5/3 and negative 1/2. So 3 times 5/3 goes in for m minus 2 times the negative 1/2 for n. 3's cancel, so that makes 5. A negative times a negative is positive, and the 2's cancel, which make 1. And we get 6 equals 6, so that's a yes for the second ordered pair. Problem 10. We have 2x squared plus 3y squared equals 57. And the first ordered pair for x and y is negative 3, 5. So this goes in for x, this for y. So we have 2 times negative 3 squared plus 3 times 5 squared. And we're checking to see if it equals 57. Negative 3 squared is 9. 5 squared is 25. I think we can see it's not going to work. 18 plus 75 is going to add up to 93, and that does not equal 57. So that's a no. Second ordered pair we're going to check is 4, negative 5. So 2 times 4 squared plus 3 times a negative 5 squared. We're going to see if it equals 57. 4 squared is 16, so that's 2 times 16. Negative 5 squared again is 25. And I think we can again see it's not going to work. That's going to be 32 plus 75 is way too much. That's 107 does not equal 57. So that's a no. And the last one in this section, number 12. We have s cubed is going to equal 4s squared t. And the ordered pair we're putting in for s and t is negative 2, negative 1/2. So we're putting in negative 2 for s. So wherever you see an s, you put in negative 2. And t is negative 1/2. Negative 2 cubed is negative 2 times negative 2, which is positive 4, times the negative 2, which is negative 8. Negative 2 squared is 4. And then we have it times negative 1/2. So we have negative 8 equals 16 times negative 1/2. This goes in 8 times, so we get negative 8 equals negative 8, since that sign was negative. So this one works. And the last ordered pair to check is 0, 2/3. So for s, we put in 0 and we cube it, equals 4 times 0 squared times t, which is 2/3. Well, since 0 times anything is 0, that definitely works, so that's a yes. And then the last part, we're to solve each equation if x and y are whole numbers. So 14, we have 5x plus y equals 7. And we want to know what ordered pairs, and they have to be whole numbers, 0, 1, 2, 3, 4, on to infinity, that we can plug in here to make this equal to 7. My suggestion to you is to start with 0 and see if you can find a y. If I put 0 in for x, there's then 7 would work for y. So 0, 7 is one solution. If I put 1 in for x, then 6 would work for y. Wait a second, I'm sorry. 2, because that would be 5 plus what makes 7. That should be a 2. If I put 2 in, I've gone too far, because that's 10. There's no way I can get to 7 unless it's negative. So those are the two ordered pairs that work. Remember, you can only substitute whole numbers, which are always positive. 16, I have 2x plus 5y equals 10. Okay, let's try the same thing again. If I put 0 in for x, is there anything I can multiply 5 by to get 10? And the answer is yes, 2. So 0, 2 works. If I put 1 in, that would be 2, and I would need an 8, and there's no whole number times 5 that makes 8. So forget 1. If I put 2 in, I get 4, and I need 6. 4 plus 6 makes 10. There's no way to multiply anything by 5 to get 6. 3 is not going to work. That's going to give me 6. I can't get a 4. 4 is not going to work. That's 8 plus, there's no way to get it. 5, if I put 5 in there, that will work. So if I put 5 in, 5 times 2 is 10, and let the y be 0. So 5 and 0 would work for an ordered pair. And then when I get to 6, that's too big. I'm past 10. And I would need negative numbers, which you can't use since we're only allowed to use whole numbers. Okay, number 18. We have x plus 3y equals 9. So again, let's start out with letting x be 0. 0 plus 3 times what would equal 9? Well, we know 0 and 3 would work. 1, I would need an 8. If I had 1 there, I would need to have this 8. There's nothing times 3 that makes 8. 2, I would need a 7. If I put 2 here, I would need this to come out 7. There's no way to get that. If I put x as 3, then I would need a 6, and there is a way to get that by multiplying by 2. Let y be 2. That will work. So 3 and 2 would work. If I put in 4, I would need a 5 here. If I put 4, I would need 3 times something to make 5. There's no way to do that. So 4 won't work. 5, I would need a 4. That wouldn't work. 6 would work. I would need a 3 here, and I can get that by letting y be 1. So the ordered pair of 6, 1 works. 7 wouldn't work because I would need a 2. No way to get that times 3. 8 wouldn't work. I'd need a 1. There's no way to get a 1 with 3 times a whole number. And then I'm at 9, and I can get that to work if I let y be 0. So 9 and 0 work. And then when I get to 10, that's too many. That's way past, it's past 9. And then the last problem, number 20. I have 3x plus y equals 7. So if I let x be 0, then y could be 7. So 0 and 7 work. If I let x be 1, that's 3 plus 4 would make 7, so 1 and 4 work. If I let x be 2, that's 6, and let y be 1, that'll make a 7, so 2 and 1 work. And then when I get to 3, that's 9, that's too much. So those are my ordered pairs that work. That concludes the evens. Be sure you check your answer key in the back for the odds.